Hey, yeah, it's Mrs. Golding. It's late again, but here we are. We're going to do some math problems for this Friday paper, number 11. I am I'm doing number 5 on your Friday paper, and it says, please put these in scientific notation. Remember, if there's no decimal in the number, if it's out of sight, it's on the right. We need to take this decimal, we need to move it to a spot where we create a number between 1 and 10. So I'm going to put that right there, 2.38. Those are the significant digits that we need. Times 10 to the 1, I'm counting, 1, 2, 3, 4, 5, 10 to the 5th. And we know that that's going to stay positive because it's a really big number, right? We're going to take this and multiply it by powers of 10 to make it equal. Now, letter B, we're going to do 1, 2, 3 powers of 10 to the right. So we end up with 2.38, which is the same as A, times 10 to the negative 1, 2, 3. Okay? Now here we're going to put these in standard form. So I have 6.2 times 10 to the 1, 2, 3. Give me 2 zeros. My answer is 6,200. For this one, 5.87 times 10 to the negative second, 1, 2. Add a 0. My answer is 0.0587. Hopefully you're getting pretty good at those. Order from least to greatest, number 7. All right. The square root of 17 is irrational. So we got to figure out what two perfect squares it's between. Square root of 16 is perfect, which is 4. And the square root of 25, which is 5. So the square root of 17 is between 4 and 5. It's closer to 4. We're going to estimate it to be about 4.1. It's probably close enough for what we're doing. 1/3. 1/3 is the same as 3/9, and anything over 9 is that number repeating. So we have this number, we have this number, we have -1, we have 5, which is the square root of 25, and then we have this number, 0.9, repeating. So are there any negatives? Because if there's negatives, that would be the smallest number, and there is, right? So the -1 is the smallest. So from least to greatest, first we're going to write down -1. Okay? We're going to cross it off because we're done with it. Now we're going to go positive, but we're going to have the smallest positive, 0.3 repeating, which is 1/3. Let's cross that out. Okay? Then we have 0.9 repeating, 0.9 repeating, cross it out. And then we have 4.1, which is the square root of 17, cross it out. And then we're left with the square root of 25. I hope you can see how to do these. It's in this case, I made them all decimals or integers so that I could compare them easier. So be patient and don't give up on those problems, because I know you have a tendency to want to just give up on those. So always just keep trying on those. This time we're going to list all of these numbers that are rational. Rational, you see the word ratio, and a ratio is just a fraction. Okay, so this first symbol is pi. Pi. Pi is a decimal that goes on forever. 3.1415926, and it's going to keep going, and it's never going to repeat. All right, that means it is irrational. Okay, square root of 36 is a perfect square, right? So the square root of 36 is 6. That's the same as 6 over 1, or 36 over 6. No. Yeah, 36 over 6 is also 6, right? Square root of 36 is rational. 1/2 is a fraction, it's rational. Negative 3 can be a fraction. It is rational. Square root of 20, is it a perfect square? It is not. It is between 4 and 5. Square root of 16 and the square root of 25. It is not rational. We can't make non-perfect squares into a fraction. Okay, this one, 0.27 repeating. We haven't discussed these very much, but any repeating decimal is rational. Repeating, rational. That's how I remember that. If it's repeating, it's rational. This is a fraction, negative 4 and 2/7. So all those that I've circled are rational, right? So those you need to put on the line as rational for number 8. Okay, so this is back to our monomials. This one, the rule is x to the a raised to the b. And in order to solve that, we multiply a times b. So this is x to the 8 times 8, which is 64. That's our answer for A. And anything to the power of 0 is 1. Just straight up 1. Okay? Let's go here. Find the values for A and B that make this statement true. Perfect square on either side of 23. 25 is perfect, which is 5 squared, right? And 4 squared, 16. I think we've been dealing with those quite a lot here on these problems. So the two values for A and B, so the value for A on your line, your answer line, could be 16, and B is 25. That's how you're going to write the answer to that. That makes this statement true. All right, we have some equations here, but they have rationals. Rational, ratio, it's a fraction, right? We're going to use the same rules that we were using today when we were talking about solving equations using integers. I'm going to use my inverse operations. Here, a negative 1 and a positive, a negative 1/3 and a positive 1/3 are additive inverses. If I add them, they make a 0, which is what I'm trying to accomplish, right? I have this variable and I want to isolate it, meaning I want to get it all by itself. So what I do to one side, I must do to the other. When I'm adding fractions, I must have a common denominator. 3 times 5 is 15, 1 times 5 is 5, 5 times 3 is 15, 4 times 3 is 12. Let's go ahead and add those. 17 over 15. Okay, so this could be my answer, or I could say x is also equal to 15 goes into 17 one time with 2 left over out of 15. Okay, so I could express it as a mixed number or improper. Either is fine. Let's go here. We're going to undo this. The inverse of add is subtract. So the additive inverse of 1/2 is negative 1/2. What I do to one side, I must do to the other. A is equal to 6/7 minus a half. I have to get a common denominator here. 2 times 7 times 7 times 2 times 2 is 12. What's 12 minus 7? 5. Very good. 5/12. Let's check our signs. Looks good so far. A is equal to 5/12. We could check that. Let's plug it in. For A, 5/12 plus a half, which is the same as 6/12, right, is equal to 11/12. So something's wrong here. Minus a half, 7/14. 14. 6 times 2 is 12. 11, 10, 9, 8, 7, 6, 5. Oh, look what I did. See, this is exactly why we plug these back in. Do you see what I did wrong? These are not going to be 12s. It's 14. See my fraction, what it should be? Always plug your numbers back in, because sometimes we make those silly mistakes. So let's go ahead and make this 5/14. We're going to check it again. I'm going to go ahead and change this one. I'm going to change this one. So let's change this out. 5/14 plus, how about 7/14? Is that the same as a half? That is equal to 7 plus 5 is 12. 7, 8, 9, 10, 11, 12, 14ths. But look, I was supposed to get 6/7. What do you notice? 6/7 is 12/14. Simplified, isn't it? If I divide by 2, I get 6/7. So I have a true statement here, so I tested it out, I checked it, and I know that A is equal to 5/14. Okay? I believe that's all of our problems we were going to do for this one. Hope this is helpful to you. Have a great day.